I'd like to introduce you to our new TPI 9070 smart vibration meter. We've put a lot of time in the development of this product. We have a built-in integral sensor right here at the top. We do band alarming to tell us if we have an imbalance, misalignment, or looseness condition just by entering the speed of the machine. The other thing we do is have the International Standards Organization's alarm levels that are built in this to tell you if you have a good machine or a bad machine. We also take our BDU readings, which is our bearing damage unit reading, to tell you if you have a bad bearing or a good bearing in the machine. We do an overall acceleration reading as well. Very, very easy to use. I hold the menu button down, it takes me into my setup wizard. At that point I just push enter. This is where I set the speed of my machine. I'm actually looking at a 3600 RPM machine, but I can cursor down or up to whatever speed I need. I'll push enter. Next it asks me for if it's a motor or pump. This is for setting up ISO alarm levels. We'll say it's a motor and it's under 300 kilowatts and it's on a flexible foundation. So now it's set up the alarm levels that ISO has programmed for a machine. Push the power button, it auto comes on, auto shuts off. I just push enter one more time, goes out to the main screen and it's ready to take readings. I'll turn the machine on, walk up to it, make contact. I just push the power button and it collects the data. You can see right there it's done. And then it brings up the overall value of the machine. It's 0.387 inches per second. These are journal bearings, so we don't have any bearing damage units going on whatsoever. The bearings are fine. Next we go to our 1x, 2x, so I can see everything's at 1x. This is my unbalance, misalignment, and looseness, so I know my machine's out of balance. If I push the menu screen, I go into my 100 line, then 200 line, 400, and 800 line spectrum. Now I can move my cursor up and down the screen right here. I'll set it at 3600, and I can see I'm at 0.3 inches per second at 3600 RPM. And I push the menu, go back to the next main screen. So the other thing we've done is we have an integral sensor, and we used an industry standard 1/4-28 threads so that you can go and put a magnet onto the device as well. Screw the magnet on, gives us a little better frequency response. Turn my motor back on. Then I just push the measure button and it's collecting the data. You can see there's the value right there on the screen again. And that's all there is